In this video, we're going to carry on looking at examples that require integration by parts. But these examples are a little bit more complex, and more complex in the sense that they might require some identities or a little trick along the way. So let's get stuck in. This first example, we're required to integrate x times sine squared x. First try and see, is it actually, can I do it by inspection or can I do it by substitution? But the problem is I've got a composite function, but I don't have the derivative of that inner function. So what we actually have are two seemingly unrelated functions, x and sine squared x. Now if you're copying this down, don't copy what I'm doing just yet, because I just want to show you your thought process here. You might think, okay, cool, I'm using my acronym LEATE. Remember, you only use the A and the T in AP, meaning that anything algebraic will be your function, not the trig. So you'd say your function is x, which makes your derivative function the sine squared x. Cool, then you go and you differentiate x and you get 1, and now you need to find the antiderivative of sine squared x. Oh, you got a problem, because there's a composite function, but there is no derivative of the inner function. So this, as we saw in previous videos, was where you invoke an identity. So let's actually just take this whole thing out and try that again using an identity. The problem we have here is the sine squared x. So I want to replace it with something else. So I've got the integral of x times, let's go to our formula sheet and see what we can replace sine squared of an angle with. Okay, so make sure you familiarize yourself. Here's your information booklet. We're going to just go to the part of the booklet that has identities. Now you might think, okay, why don't I use this one? That's sine squared of an angle. But it would give me 1 minus cos squared of an angle, and I've got the same problem of a cos squared. So there must be another formula somewhere here with a sine squared of an angle. Ah, there we go. This one says cos of 2 times an angle is equal to 1 minus 2 sine squared of an angle. So I want to rearrange that. So sine squared of an angle is the subject of the formula. If I start to rearrange, I've got 2 sine squared of an angle is 1 minus cos 2 of an angle. Divide by 2, which means I've got a half minus half cos 2 of an angle. And that's actually a really nice one to learn, even though it's not on the information sheet. Right, so we're going to replace sine squared of an angle with half minus half cos of 2 times an angle. Now it's going to be much easier to integrate something that has cos 2 times an angle. At this point, you could go straight to integration by parts, or you could distribute the x in and split up your integral, which I find just to be a little bit easier, a little bit less to work with overall. So I'm going to do that. I'm going to distribute that x in. So if I do that, I've got the integral, and I'm going to split the integral straight away. So I'm not going to put in every tiny little step. I've got the integral of x times a half, which is half integral of x with respect to x. Then I've got, here's my minus, and I distribute that x in now to the second term. And immediately I can take that half out. So it's a half integral of x times by cos 2x with respect to x. So this I don't need integration by parts for. I can integrate. This is the portion that I will use integration by parts. So let's first start by working with that. I've got my half. The integral of x is x squared over 2. So that's taken care of. Minus a half. And now I'm going to have to do that whole story there. This will be integration by parts, so I'm going to bracket it off. Okay, so let's actually have a look here. There's my x and my cos 2x. I've got a product, but I can't use inspection because I don't have the derivative of the inner function. So I'm going to go straight to integration by parts. And I'm actually just going to use this section up here because it's some free space. Alright, so I'm going to choose my function. Let's use some colors again. So I'm going to choose my function to be x, because remember your acronym LIATE, and in AP you only use the a and the t. The a means you choose the algebraic function, which is x, which makes my derivative function cos 2x. Okay, now if I go and I differentiate x, I'm going to get 1. And if I integrate cos 2x to find the antiderivative, so I find the antiderivative and I get half sine 2x. Right, so let's sub that all in over here using our formula. Now, just so that you are convinced your formula is on your information sheet, there it is. They just add in the constant of integration. So if I've got the integral of a function times the derivative, it's f times g minus the integral of g times the derivative of f. So actually, I think I've got it here. Let me just pop it up there for you so you can have a look at it. You would be looking at your information booklet right now. So let's pop in what we need. I've got f times g first. So my f is just x multiplied by g, which is a half sine 2x. So that's a half sine 2x. Remember the next part of my formula says minus the integral. So minus the integral of g. So that's half sine 2x multiplied by the derivative of f, which is just 1, and I'll still just pop that 1 in there. Just notice my use of brackets here because only this portion here, only this portion is integration. Actually, let's just, only that portion there is requiring integration by parts. So that's why I've put in these brackets. So those brackets are very important. And I'll choose to just handle what's in those brackets first and then multiply my half in later. Obviously, you can multiply in earlier. It's just personal preference. Let's pretty this up a little bit. A half times x squared over 2. That's a quarter x squared, or x squared over 4. I'm going to leave my minus a half at the moment. Multiply it in later. And just pretty this up a little bit. That's a half x. A half x sine 2x. Now, let's have a look what we've got here. I can take this half out. So I've got minus a half, and I'm integrating sine 2x times 1, which is just sine 2x with respect to x. Okay, so now while I'm integrating that, the integral of sine 2x, remember I go to my table. Here's my table. And I see, do I have sine of an angle? No, but I've got negative sine of an angle. So I need to make sure that that is negative sine. So remember, I can pop a negative in as long as I take out a negative, making that a plus. So that's how I've got plus a half negative sine 2x. Everything else stays the same. I prefer to times my half in later, just so I don't make any mistakes. So here I've got half x sine 2x plus a half. That's the half that's already there, times the integral of negative sine 2x. Go to your table. Negative sine of an angle. The integral is cos of an angle. So it's going to be cos of an angle, but because of that 2, to undo the chain rule, I've got to put a half cos of my angle, which is 2x. I finished integrating, so I've got to add my constant of integration. Now I can times in that negative half and just pretty this up a little bit. So I've got a quarter x squared. Let's times in that half. I need to times it in here. And I also need to times it in over there. So I'm going to get minus a quarter x sine 2x. Then I've got a negative and a positive. So negative, a half times a half is an eighth cos 2x. And my constant of integration will always be c, so it doesn't get that negative half times in because it's a constant regardless. Right, so just keep your wits about you when you're doing a question like this. They do get very long, but as long as you keep breaking it up, that's why I use the brackets, just to make sure I know that I'm on track. Cool. Let's try another one. Right, in this example, I've got the integral of x times sine x times cos x. Now I search for a function and its derivative, but the only problem I've got is this other x. So I've got some seemingly unrelated functions. And I don't know about you, but it doesn't sit well with me that I have x times sine x times cos x. So perhaps there's an identity that will allow me to replace sine x times cos x. Let's go look at our information sheet. So I have a look at my sheet, and I see, is there anything that has a sine of an angle times by cos of an angle? This does, but wait a second, there's just too much other stuff going on. So I'm going to go with this one. Sine of 2 times an angle is 2 sine of an angle times cos of an angle. So if I isolate sine of an angle times cos of an angle, it's the same as half sine of 2 times an angle. I'm going to use that one. So here, this is the same as the integral of x multiplied by half sine of 2 times an angle, which is going to be much easier to work with. So I'm going to use that. Let's just, I always like to take my constant out. You really don't have to. It's a personal preference. I just don't like that constant to be involved because I feel like I can make my life simpler without it. So I'm going to be doing integration by parts on this section here, not including that half. So let's start out by identifying our function and our derivative function. Now, our function will be the algebraic one. Remember, that'll always be your first choice for your function. So my function is going to be x, which means immediately my derivative function will be sine 2x. Alright, so now let's differentiate. The derivative of x is 1. And I want to find the antiderivative here of sine 2x. If you need to, just go back and say, well, I'm integrating sine 2x. This can definitely happen in your head. According to my table, if I want to integrate sine 2x, I need a negative. So I pop a negative there and there, which gives me negative. And because of that 2, I've got to counter it with a half. Cos 2x plus a constant of integration, but I just care about that part there. That goes over here. So I've got negative a half cos 2x. Cool. Now I can go to my formula, so I don't need it sitting there anymore. Let's put it in this example for us. Go check out your formula on your information sheets. I'm going to keep going back here just so you can see where it is. There's your integration by parts formula. I'm just going to pop it over here so that we've got it in front of us. We can use it. Right, so I need f times g. So therefore I'm dealing with f times g. Now don't forget that there's a half sitting outside your integration by parts, because the only thing you're doing with integration by parts is that. So my half still sits outside, and then I've got my f times g, which in this case will be x times by, and I'm going to put it in brackets because of the negative, negative a half cos 2x. Then the next part of my formula is minus the integral. So minus the integral of g, which is negative a half cos 2x, multiplied by the derivative of f, which is just 1 with respect to x. Cool. Let's now have a look. What can we pretty up? What can we integrate? So I'm not going to times my half in just yet. I first just want to pretty stuff up and handle the integrals. That becomes negative a half x cos 2x. Then I've got a minus and a minus is a plus. That half can come out, and I'm integrating cos 2x times 1, which is just cos 2x. Alright, the integral of cos 2x, that'll be quite straightforward. So actually in this case, if you see that that half can times in straight away, why not? So I'm going to times that half in as I'm working. So this becomes negative a quarter x cos 2x plus, half times a half is a quarter, times the integral of cos 2x. Go to your table. Here we go. I see cos of an angle. The integral is sine of an angle. So it's sine of an angle, but because of that 2, I've got to have that half to counter it. So it's a half sine 2 of it times an angle. Because I finished integrating, I've got to add my constant of integration. Just one more step in prettying it up. That is plus an eighth sine 2x plus my constant of integration. All right, let's look at one more example. Take a breath. I know they seem long. The more you practice, the better you get at these. So let's have a look at our next example. Let's just take our formula down here. Okay, let's look at our next example. Here I'm integrating 3x times sine x times cos squared x. So we have a look here, and you might feel a bit uneasy because you see your three functions. However, in this case, can you see your sine x times your cos squared x? You see a composite function, but the inner function is cos x, and you do see its derivative. So it is something that I can work with. No need to go to identities, because my one function is 3x, and the other function, this guy, I'm going to be able to use inspection to do. So, personal preference again, I like to take out the constant and not have it be part of my integration by parts. But again, it does actually work if you have it as part of it. I just find it a little bit easier, so I'm just going to use integration by parts for that. And let the 3 sit outside. So let's start. Again, choose your function to be the algebra, the algebraic expression, which means that my derivative function is going to be that whole story here. Sine x times by cos squared x. So here, the derivative of x is 1. And here, I want to now integrate. So let's, remember it can happen in your head, but let's just do it over here. I want to integrate sine x times by cos squared x with respect to x. I can do it by inspection because I see a composite function and I almost see the derivative of the inner function. Go back to your table. The derivative of cos x is negative sine x. So I would rather see a negative. So let's put that negative and counter it with another one. So this is cos cubed x over 3 plus a constant of integration. And often it's easier if we're going to work with it further to see it as the third cos cubed x plus c. That is the portion that you need to put in here. Oh, and I forgot my negative. Don't forget your negative. So it's negative a third cos cubed x. And now we can go to our formula. So remember, it's on your information sheet. There it is. I'm just going to pop it over here again so we've got it right in front of us. There's your formula. So remember, when we start our formula, we're going to have f of x times g of x. And don't forget your 3. Your 3 that's sitting outside. So f of x times g of x, I've got x times by, use brackets because it's times by something negative, negative a third cos cubed x. Next part of my formula is, oh, and let's actually stick to our colors. I forgot about my colors for a moment there. So let me just quickly rewrite that in blue. Negative a third cos cubed x minus the integral of g of x, which is negative a third cos cubed x, multiplied by the derivative of f, which is 1 with respect to x. Don't forget to close those brackets. Alright, so again, I'm just going to leave my 3 outside for the moment. We'll see soon enough if we can times it in. Pretty this up a bit. I've got negative a third x cos cubed x. Then a minus and a minus is a plus. I can take that third out. And I'm integrating cos cubed x with respect to x. Cool. Now here it's actually quite easy to see that the 3 can multiply in because of that third. So let's multiply it in. 3 times negative a third is negative 1, so it's negative x cos cubed x plus 3 times third is 1, and I'm integrating cos cubed x. So I go and have a look first at my table. I don't see a cos cubed x here. So let's just check my identities. Scan through them. Oh dear, I don't see a cos cubed of an angle. So if you land up with that uneven power, what you can do, and this is kind of a little trick, so I'm just going to put a little star there. It's like a little trick. Is you can rewrite cos cubed x as cos squared x multiplied by cos x with respect to x. Now, the reason why we do this, let's have a look. Cos cubed x plus. Now, according to our identities, let's go back to our information sheet. I can rewrite cos squared of an angle as 1 minus sine squared of an angle. So I'm going to rewrite cos squared x as 1 minus sine squared x. Don't panic. Once you've seen me work through this example, you'll know when to use it in future. So times by cos x with respect to x. Alright, keep going. Just rewrite this guy. Because what I can now do is I can split this. I can distribute that cos x in. Again, just hang tight. You'll see there is method in my madness in a moment. If I distribute it in, 1 times cos x is cos x minus sine squared x times by cos x with respect to x. Rewrite that guy. So now what I can do is I can split this. That's the integral of cos x with respect to x minus the integral of sine squared x times cos x with respect to x. Now these all become easier integrals to work with. So I've got negative x cos cubed x plus the integral of cos x is just sine x minus, now you'll see that because I've got a composite function and the derivative of the inner function, I can do this by inspection. So that just becomes sine cubed x over 3 plus c, or a third sine cubed x. Sure, that one was quite a tricky one, but don't forget this little trick here. If things just aren't working, replace one of those, the cos cubed x, replace it with cos squared x times cos x, invoke your identity so you can split it, and you can then do one by inspection.